Hi all, this is Balaji, Assistant Professor, Department of Mechatronics Engineering, SNS College of Technology. In this last video, we have discussed about the external gear pumps and the internal gear pumps. So, the external gear pumps, which has two gears in internal and external in the same parallel line. It has some shaft in the same parallel line. By using this external support motors, it works. So finally, it has some advantages like non-pulsating discharge, extend for high viscosity fluids, and then it can operate well in either directions. Constant even discharge regardless for pressure conditions. It can be made operate with one direction flow with either rotation. So easy to maintain and single adjustable and clearance. Okay, so it has some disadvantages like usually requires a moderate speeds and then medium pressure limitations. Okay, so these are the some important disadvantages about the external gear pumps. Okay, so next we are going to discuss about vane pumps. Okay, so vane pumps, it has some two type of pumps are available. One is a balanced and the unbalanced pumps. Okay, it used for can handle the low viscosity fluids. Okay, and also it has works on minus 25 Fahrenheit to minus 35 Fahrenheit. Okay, so and it works on suitable for the up to 200 bars of pressures. Okay, above for the hydraulic pumps. Okay, for those application we can use these van pumps. Okay, so in the screen you can see the unbalanced van pumps available. So basically van pumps are rotating rotor with movable vanes. Okay, this vane slides move to the two kind of slots. So initially I said about the it has two kind of pumps are available. One is unbalanced and the balanced. So in this crane, you'll be having the unbalanced vane pumps. So basically, the unbalanced pumps it has some rotor. The place is eccentrically inside the cam ring, and then vane slides are upward due to centrifugal forces. And then as rotor rotates, the spaces between the vanes increases in the inside inlet slides, and then fluid enter through the chamber. And then as rotation continues, the space decreases on the outlet sides. The fluid discharge, and then in the advantages it has some smooth flow and then good efficiency and then compact designs too. Okay, however, the pressure difference between the side loading on the shaft, which may reduce the bearing life. Okay. Next, we can see about the balanced vane pump. So the balanced vane pump to solve the shaft loading issues, people are using the balanced vane pumps. Okay. So inside the design, it has some cam rings in elliptical and two inlet ports and two outlet ports are provided, and then in pressure forces are in the opposite directions. Okay, so those results canceling each other. No net side load on the shaft and the longer bearing lives, better reliability and an improved service life. Okay, so balanced beams are perform the industrial hydraulic applications. Okay, so basically we'll be having a many kind of advantages in in your van pumps. So van pumps can handle the thin liquids like you can say the low viscosity fluids. Okay, and then it has some self compensating wear, can run the dry briefly, and then good vacuum performance available. So finally it has some disadvantages available. It can work on more complex design and suitable for very high pressure, and then poor performance for abrasive fluids. Okay, so basically you have to think about these van pumps while if you are using the low viscosity fluid for the fluid flow we can use the van pump. Okay, so the balanced wave pump features a typical cam ring which has two inlet ports. Already we have discussed. So pressure loading occurs pumps into two identical pump valves, create the equal and opposite forces, and the rotor leading in zero net forces. Okay, so these are some important points we have to add. So thank you for watching. Thank you.
Right, that ain't me.